Let's say this is you. You're building a video game where the player speaks normal English to a merchant and the merchant has to actually understand it. Maybe the player says something like, hey, I want to give the merchant an apple, or here's an apple, or hey, can you add something to my inventory? So you, being smart, figure out that you want to use Python. You want to use some fancy functions, but functions are algorithmic and they're strict, and they can't handle messy human English all that well. So you use a model, because you're a smart student, and this model can output something called JSON. The model can turn messy human English into something that always has structure and that's always consistent. That way our functions can read it every single time. Basically, this is a pretty good idea, and I think my group thought so as well. So let's see how this works. First, we're looking for an AI model, but there's a lot out there. We have ChatGPT, you ask it what to eat for breakfast, and it gives you an entire novel. But we don't really want a novel. We want something reliable, simple, and short. In this case, less is more. Stability matters after all, so we start looking around at machine learning models and we land on Hugging Face community. Now, Hugging Face has more models than anyone will ever need. We started off with something like Zephyr, pretty good, highly rated, nice and simple, but again, not quite struct enough. We needed something more rigorous at the end of the day. That is where Pi 3 came in. It focuses well on memory, latency, and strong reasoning, something that could work pretty really well and maybe give us JSON reliably. Let's take a look at how this works really quickly. So the first chunk is kind of just the setup. It's the same, installing files, sorting out problems with wheels, compile errors. We eventually got everything working. And here's where the magic happens. When training a model for something like this, you have to give it a lot of data, right? A lot of examples of, hey, here's what I expect you to do. Here's exactly how you should do it. In our case, we needed the model to follow very strict rules, like always output JSON and always include an object and a response and an action, which I'll get into more later. We need something that our Python functions can always read, and we need something that the players can understand. Something like a response that the players can read off the bat, and then we split the model into responses and personalities. This basically takes whatever the model sees and makes it spit out what we want. So we have what the merchant says back to the player, like, sure, have an apple, thanks for your patronage. And we have the object and the action. So how does this all work at the end of the day? Let's say you have an inventory, a sack, or the merchant's inventory for this case, and over here is basically our model. This is our bridge. It takes the player speaking natural English, take this, or here's an apple, and figures out what to do. You program your model to look for keywords. For example, if the player says, take this, the model sees the word take. And now the model is going to output JSON describing that action. Python takes over, and then hopefully it updates the inventory correctly. Let's go back to the code really quick. We wanted the code to only use 3 kinds of actions: give, take, or do nothing. Action is what the machine learning model outputs, and what's what gets fed into the functions later. We build a function with a prompt, and then process action takes the response from the model, checks it, and either gives the item, takes the item, or ignores it. We wanted the code to only use 3 kinds of outputs: give, take, or do nothing. Actions. Action is what the machine learning model outputs, and it's what gets fed into the functions later. So again, we have response, objects, and then actions. We have response, a human readable line, like here you go, here's the apple. We have an object, which is the item that we're talking about, and then we have the action, give, take, or do nothing. That is all we want the model to output after we give it human readable English. The most important piece, like I said, it's the question mark. If the model output ends with a question mark, that means, hey, ignore all actions. Don't take, don't give, just focus on responses and focus on actions. So for example, what do you have in your bag ends with a question mark? No action. Or give this apple to a merchant ends with a period. Action could be allowed, and that would need to do for some Python. So let's see this actually in example with a lobster. We start with an inventory of a pear, banana, and an apple. No lobster yet, but that's going to change in a second. Okay, we ask the model, hey, do you have a lobster? And surprisingly or unsurprisingly, it says, I do not have a lobster in my inventory, and notice how the option says none, and there's no action right now. Now, take this lobster. Enter the period. The model sees the word take and it outputs, okay, action is going to be a take, object is going to be a lobster, and goes, okay, sure, take the lobster from the player. Python then adds the lobster to the merchant's inventory. We ask it again, do you have a lobster? Surprisingly, yes, we have a lobster in inventory, and object is the lobster. It's saying that, there's no action, it's just answering a question because we have that question mark. Then we ask it, do you have a crab? Nothing right here, unsurprisingly, object none. We ask it, hey, can I have the lobster back? It gives you back the lobster, targeting the lobster as the object and the action give item to a player. The Python function feeds the lobster back into the player's inventory. When we ask it for the last time, do you have a lobster? It does not have a lobster in its inventory. So, let's draw this one out. Player hands over a lobster by saying, take the lobster. Take is our action, the object is the lobster. Python removes the lobster from the player's inventory and updates the inventory. Then the player is going to go ahead and ask it a question. So you can see we take the lobster, the machine learning model feeds it into the Python function, and puts it in the inventory. Player asks a question, hey, do you have a lobster? We throw basically everything out. Remember, completely ignore any sort of actions and focus on a response, which is where our guy goes, yeah, I have a lobster. Thanks for asking. No Python needed. Finally, we say, give me the lobster. So accordingly, action is the give, object is the lobster, machine learning model sees that, once again feeds in the Python, and we give the lobster right back to our player. And so what do we learn? Our model looks for keywords like take, give, obtain, anything like that, and translate them into JSON instructions. Then Python executes those instructions every time. Again though, the biggest hero here is the question mark. No take, no give, just focus on respond and prevents actions. If we have an exclamation mark or a period or nothing, that means that we can respond, we can do takes or gives, there can be an action, but also still focus on the response. Unfortunately, we found a few problems with our model so far, and we're trying to fix them, but here's what we have so far. If we try to trick the model by giving it a weird question like, give me a list with no question mark, the model might actually see the word list and give and think that we're trying to get a list out of its inventory, instead of the model just printing off a list of all things. So, use the question mark if you want to know all the lists. Say, hey, what's in the bag? And the model could probably spit out everything. Use the periods or nothing else to do any sorts of actions. That's basically all we got. Hope you understand, and thanks for tuning in for us.